Welcome everyone. In this video, we are going to see about silicon control rectifier. In short, it is called SCR. Actually, it is a basically a four-layered semiconductor device which can be used in various switching applications. So, silicon control rectifier is a four layers of alternate type P and N type semiconductors forming three junctions. So, the structure will be like there's a four layered. There will be two PN junction or two transistors. So PN, another PN. So there will be a three junction. Junction one. This is junction two and junction three. This is two PN diode forming a SCR or two transistor one PNP or NPN transistor forms a SCR. So the terminal connected to the outer P type is called anode. This is the anode, and this is a three-terminal device: anode, cathode, and gate terminal. So this is the cathode, and we have the gate terminal here. This is the gate terminal. So it is a bipolar blocking device, unidirection, conducting device, and pulse triggered device, pulse triggered switch. So it is a semi-controlled switch where we can control by the device. So the SCR is so called because of silicon is used for its construction and its operation as a rectifier. That is very low resistance in forward conduction, very high resistance in the reverse direction can be controlled. So an SCR blocks the current flow from anode to cathode, until it is triggered into conduction by a proper gate signal between gate and cathode terminal. So here it operates in the three mode. So one is the reverse blocking mode and forward blocking and forward conducting mode. So, so in the reverse blocking mode, when cathode is made positive with respect to anode with the switch open, the SCR is reverse biased. Junction J1, J2, J3, in which whereas J2 will be the forward biased. So this terminal is in J2 will be forward biased, J1 and J3 will be J1, J3 will be forward biased, and J2 will be reverse biased. In case of forward blocking, in case of reverse blocking, J1 and J2, J1, J3 will be reverse biased, and J2 will be forward biased. And a small leakage current of the order of very few milliamperes flows. This reverse blocking mode is also known as off state of SCR. If the reverse voltage is increased, then critical breakdown level called reverse breakdown voltage and avalanche occurs at J1 and J3, and the reverse breakdown voltage increases rapidly. A larger current associated with breakdown voltage give rise to more losses, leads to damage of FCR. Therefore, the reverse voltage across SCR should not exceed the breakover voltage, reverse breakdown voltage. When reverse bias applied across the SCR is less than, in short, we call it as a VPR, the device offers a high resistance in reverse direction. Therefore, SCR in reverse blocking mode can be treated as the open switch. So you can see here. So up to this is breakdown voltage, we can call it as a VBR, reverse. So until we are, it will be in high resistance mode. So there will be a small leakage current. So due to minority carriers, we should be careful. It should not exceed the reverse breakdown voltage (VBR) in the reverse blocking mode. So in the forward blocking mode, when anode is positive with respect to cathode, so this is where it will be forward biased, and is positive with respect to uh, uh, cathode. So with gate circuit open, SCR is said to be forward biased. So in this mode, junction J1, J3 will be forward biased and J2 will be reverse biased. So in this mode, a small forward leakage current flows. If the forward voltage is further increased, so when you look at here, so there will be a small uh, forward voltage due to minority carriers. So until this is called the breakout voltage, we can call it as VBO, breakout forward breakout voltage. So when forward voltage is less than VBO, SCR offers high impedance. Therefore, SCR can be treated as an open switch in the forward blocking mode. So forward conduction mode. So in this mode, SCR conducts current from anode to cathode with a very small voltage drop across it. So SCR is brought from forward breaker voltage to forward conduction mode by turning it on by exceeding the breaker voltage and by applying gate pulse between the gate and cathode. So when it is forward biased, so when we are applying small, that is the gate voltage, this is the gate voltage between these two terminal. So it will the SCR will go to on state. It will crosses this breakout voltage. It will go to the on state. So in this mode, SCR is in on state and behaves like a closed switch. So voltage drop across SCR is in the on state is of order of 1 or 2 volt depending on the rating of SCR. So this is called the forward conduction mode. So this is called the holding current, and this is the latching current. So latching current. This is latching current. So latching current is nothing but the minimum value of anode current which it must attain during the turn on process to maintain conduction when gate signal is removed. So it is associated with the turn on process. Holding current is nothing but the minimum value of anode current below which it must fall for turning off the SCR. It is associated with turning off process. So and we can say that it can be used in different applications. Uh, for controlling. So it is very much useful, and also it can be used um, lamp dimming and also power regulators and motor controls. It finds the numerous applications. Thank you.